All right. So today we're going to talk about rational equations, okay? And we just got to start 1 second. What's rational equations? Has the word ratio in it, like 2 to 3, which is a fraction, 2 over 3, 2/3. Anything with an equal sign, because that's an equation, and anything with fractions is a rational equation. When we do rational equations, and again, I have a pretty simple one here on the board, right? 1 and 1/2 x minus 3/4 equals 1 3/4. We could do this the old-fashioned way, right? And we could say, hey, we could add 3/4 to both sides, get 1 and 1/2 x equals 1 6/4, right? And then I make that ugly, icky number into 2 1/2, and then I can divide both sides, and I can do all the work, and I get 5/3. And for this problem, that's pretty easy. In fact, I might do it that way. But as these rational equations get more complicated, we want to get away from dealing with fractions. It just leads to errors. And if you have a calculator, it's one thing, but if you don't, it's another. So the first thing, and often even if I'm going to solve it the old-fashioned way, I would start from improper fractions. But I get to this step, and I realize that I can do anything I want as long as I do it to both sides of the equation. I have 3 terms. So the question I see is, I see 2, 4, and 4. What's the least common multiple of that? Well, it's 4. Now, a lot of students might say 8 by accident. A lot of students might say 32, 2 times 4 times 4. It'll still get you the right answer, but you're going to have to simplify the last step. But I'm going to go with 4. So, all right, so, hang on, come on. So, I do not have to put up with fractions or decimals. If I have an equation, I do not have to do fractions or decimals. So I am going to take that first equation here, and I am going to multiply everything by the least common multiple of the denominators. And if I do that, the fractions will go away. Now, often students are brain locked here, and they insist on going 4 times 3. You don't really want to do that. I see 4 times 2. I see 4 over 2 is 2. I see 4 over 4 is 1. I see 4 over 4 is 1. All right, and when I do that, I get an equation here of 6x minus 3 equals 7. And we're getting so good at equations now in algebra that this one we probably could do in our head. But we'll do it longhand. And it has to come out the same. It comes out to be 10/6. Divide both by 2 and you get 5/3. Same answer. It has to be the same solution. And you might say, well, Mr. Anderson, I don't see that as easier. I think maybe doing the original method over here, it's the same amount of steps. Well, here it is. You got to divide fractions. How many of you guys really can divide 2 1/2 by 1 1/2 that quickly? Not many students. But realistically, we're going to come up with much more complicated rational equations, like these two. All right, I got a green one on the left. I got a blue one on the right. We're going to start with the green one. And it's not too bad again. You see y over 2 plus 1/4 equals y over 6. 2 variables, right? Variable on both sides. We don't want to freak out, but at the same time, this would get a little more complicated if you left it as fractions. So our first step, let's pitch away the fractions. There's an equal sign, and I don't have to put up with them. So I have to think, what's the least common multiple of 2, 4, and 6? 2, 4, and 6. Now, a lot of students might say 24. A lot of students might say 48. But I know 2, 4, and 6 go into 12. All right? So I'm going to multiply all 3 of these at this point by 12. And I'm going to actually write that step because I show that I'm doing every term both sides. And then I'm going to do the reduction. 12 over 2 is 6. 12 over 4 is 3. 12 over 6 is 2. And then I'm going to do the math. I get 6y plus 1 times 3 is 3. Oh boy. Now, don't move the 2y over here this time. You see 3's here. Let's save some work. I'll move the 6y. And I'll get 3 equals negative 4y. Divide both sides by the negative 4. Again, make sure you grab the sign. And I get negative 3/4 equals y. Y is negative 3/4. There is no way, if you try to find a common denominator, you'll be able to do it that quickly. All right? So, when we look over at the other problem, now this one's a little different. It's going to be a little bigger. I have 2x minus over 7 minus 3x over 2 equals 1/3. I got like terms. Now you could find a common denominator of 14, right, and combine them. But my argument is let's not waste that much time, all right? And there are some tricks here that can be done. First of all, if you try to figure out the least common multiple of 7, 2, and 3, hopefully you catch it. 7's prime, 2 is prime, 3 is prime. 2 times 3 is 6. 6 times 7 is 42. Well, writing 42 up here gets a little complicated, right? Because what's 42 divided by 7? So sometimes when I have primes, I would just write out all 3. I have 7, 2, and 3. I can multiply by 2, 7, and 3, 2, 7, and 3, 2, 7, and 3. And by doing that as primes, I think you'll see the numbers easier. Because now the stuff just cancels. This is all one product. It's all factors. No addition here. You notice I'm not canceling the 7 to this 7. I'm canceling this 7 to that 7. 2 to 2. 3 to 3. And now I have math I can handle. 2 times 2 times 3, I get 12x. 3 times 3 times 7. 3 times 3 is 9. 9 times 7, 63. 2 times 7 is 14. And in just a couple seconds, I have created a problem that we could do, very easily. So I add 63. I get 12x equals 77. Divide by 12. How about 77 twelfths? There is no way you would be able to do that finding common denominators. And most likely, you'd probably be borderline math mistakes. All right? And these are nice. And again, problems like this you can do. The real power is when it gets even uglier. Here I have sums over numbers. I still have 3 terms. We should see that there's still 3 terms. And this is how we start. But again, I hate fractions. And when I have an equal sign, when I have a rational equation, not an expression, I can get rid of all fractions or decimals. So the first thing, again, is to figure out the least common multiple. But the other thing we got to realize is that x plus 1 is one thing, and 2x minus 9 is one thing, right? We have to put those in parentheses first, or else we'll have all kinds of problems. 4, 2, and 10. Again, not 40, not 80. 4, 2, and 10 go into 20. So we'll multiply everything, all 3 terms, by 20. And this is one of those times I'm actually going to write out the step. 20 divided by 4 is 5. 20 divided by 2 is 10. 20 divided by 10 is 2. So my step here is 5 times x plus 1 minus 3 times 10 equals 2 times 2x minus 9. And the reason I do this step is that you can see now it has to distribute, right? All too often students have the 5 right here, and they take 5x plus 1. And it's not 5x plus 1, it's 5x plus 5 minus 30 equals 4x, not minus 9, 4x minus 18. And now this is a problem we can solve. And it's much more, just 3 steps. We have gotten to a green equation that's all integers, all on one line, completely in our wheelhouse. Combine like terms, I get minus 25. Get the x's on one side. I get x minus 25 equals negative 18. So I'll add 25 to both sides. Minus 18. I said it, but I didn't. There we go. And I get x is positive 7. Again, rational equations, all right? We need to practice this, all right? But one of the things in my classroom that will be a necessity is I will not let you give me the answer without giving me this equation, all right? We have to be able to do this skill, so I will always demand that you show the integer equations and rational equations. Keep practicing.